Okay, welcome back. Today we're doing the next video in our series on computer chess software. The program we're looking at today is QChess, which is a GUI but also a command line tool for running engine chess tournaments. Now, I always think about that in terms of being almost like a dungeon master, where you line up one engine versus another engine, same idea of monsters versus player characters or different monsters groups, and see which are more powerful than others. So obviously with QChess, we're thinking about matching engines versus engines. We could be talking about the very powerful open source ones like Stockfish, or you could be developing a engine of your own, and QChess gives you the ability to match it against other chess engines. So that's what we'll be going through today. Building a QChess from open source software, GitHub. Let's quickly switch over to the Unix screen here. QChess on GitHub. So we can just quickly search for that. I had it open before. And then that would be the URL you'd attach to it. And as I said, I've already done that. And here is the QChess. Now, most of the actual programs, if you want to look at them, are in projects. There's the command line tool and the GUI. As you see, a lot of C++. It uses the Qt5, a set of packages which you use, and it helps you basically control, screen widgets and input and output and so on in cross-platform manner. Now, because we've probably got other applications which use Qt5, you may or may not need to load it on your system if you're doing the build. So if you look at that page, I just list out there's a lot of bits and pieces to the Qt5 package, and you'd probably best to sort of run it, see what you're missing, and you can see you basically just install them as you need them, and then you'd be able to run QChess. Now, if we just look at it very quickly, we'll go back to the way it instructs you to build it. It says, if you look at this, it says make a directory build, go to build, and then do those steps. So actually, I've done it before, but you can have a look. It's saying do cmake ... from directory above, and then make actually makes it build the target. So there it is. And if you look at the directory now, you can see that there is two files here, QChess, we'll use that quickly, and QChess CLI, which is the one which we'll get more involved in. So let's just see if we run QChess. And what we're interested in doing, if you go to tournament new, this is how you can set up a chess tournament. What's the name of the tournament? How many rounds it is, how many games per round, what type of tournament it is, and then over here you've got the time controls and so on. You can also force it from an opening Venn position, and you can allow the computer to be using opening books. Now, we don't have any engines here, so to get it all running, close out the tournament bit, and we'll go Tools, Settings, Engines. Okay, so I did this briefly before. Basically, you set up engines. If you double click into it, you can see that you give the engine a name, you tell it what the command is, you tell it the directory to go to, and then the engine, it will be able to connect to the engine when it's running the tournament and do the analysis. So since we've got two engines, Stockfish and Stockfish 1, they're both Stockfish, we can do new tournament. You go over here, you add players, add Stockfish. I don't know if you can do it all at the same time, but anyway, you've got two Stockfishes. Let's do a faster one, 40 moves in 1 minute. And that's it. We can just go okay, and the tournament starts. And this should be playing pretty quickly because we've just given it 1 minute for all moves. Yeah, so however, let me stop that. Good note. Yep. So that's what you can do. You can do a big tournament. You can watch it while it's playing. You probably won't watch it while it's playing because if you're testing engines or you're testing a new engine you build, you're most likely just want to run a lot of tests and go away and come back when the answers arrived, which is where you get on to using QChess, the command line. Let me just copy that. So I'll run the command line, and then you specify engine. I mean, this is a bit fiddly, but I mean, once you've got a script doing it, then. And then proto, I mean, this is protocol. Normally you'd be using UCI, and then 10 plus 0.25, I think, is 10 seconds plus 0.25 seconds. And there it is, Stockfish playing Stockfish. Right, okay, we can stop that. I'll just show you another thing you can put in here, concurrency 10. And now, depending upon how many threads you have, it's playing all 10 games at once. You can see the idea here that you play one engine against another. And I just stopped that because one more thing you probably want to do is, I think it's, you need to specify a file. PGN, out.pgn, see if it does what I want. It will be pgn out. And now, same thing, started 10 games up, and this time it will save the games in the output. Okay, welcome back. I actually stopped the recording, although it actually only took another minute or so to finish all those 10 games. You can see there was one decisive game, Stockfish versus Stockfish. I mean, obviously with this short time control, there are some errors, and then you can see this little analysis line where it thinks one Stockfish is 35 points stronger than the other Stockfish. So, you know, I think that if you ran more games and or probably played a longer time control, you'd find that Stockfish versus Stockfish, most of the games end up being draws. Okay, so now we're going to have a little bit of fun. Let's first of all, let's do something very quickly. Well, actually, I'll leave that in build. I'll just use another tab. This one's in directory called Balrog. It's absolutely Stockfish, but you'll see the files there. Now, one of them is misc.cpp. Just some miscellaneous functions here. One of them is the info. When this is UCI protocol, I believe. The caller, you know, what's your name, right? And then you can see this goes Stockfish, and then it does quite a bit of analysis, you know, which date is Stockfish from, and then also gives a sort of hash value. But we're not going to do any of that. We're going to go down here, and we are going to return, just to copy that so there don't cause any big problems later on. We're going to return Balrog. This is the Balrog. And we'll have to make it again, so that we make, be any problems. Oh, make -j build arch equals native. Remember that it should only almost be compiling that one file I've changed, so I'd hope it to be pretty quick. Yeah, I think it's already doing the linking. Right. So we've got Balrog. Balrog's being made, and then I'll go across to Stockfish, and I'll do the same thing. I'll go to misc.cpp, and I'll look for the info procedure. Because I'm lazy this time, I'm just going to go here and go return and it's purely cosmetic. Don't do this and try and claim you've made a new chess engine with a different name. Once again, it should only be compiling that one line of code in one file. Now it should have Gandalf. So now we go back to chess. So that didn't work well because what I want to do is the second version of Stockfish. I don't want to look at Stockfish. I want to look in the Balrog subdirectory. And now I got Gandalf versus Balrog, which is kind of what I was after all along here, right? So of course both versions of Stockfish are exactly the same. Haven't made any changes yet. However, this is where I'm just a bit of fun, right? Let's see how it is, right? Paraphrasing Gandalf. You shall not en passant. I'd be curious to know the ability or capability of an engine to do en passant. Well, actually, the chess engine, which didn't understand it, couldn't make those moves. How much strength would you actually lose if that was the case, right? So what I'm going to do is go back to the Balrog's code and stop Balrog from considering en passant moves. And I think going through these steps, that process will help us understand a little bit more about how chess engines work in the move generation phase. Right, well, I've been talking, this guy's been running away in the background. Let's have a look. We have, so far, it's all draws this time around between Balrog and Gandalf. So when that last game summary comes through, I think let's see, we're pretty sure that it'll say the ELOs are the same. There we go. So that's realistically what we would be expecting. 50-50, 50-50, ELO difference 0. the next step, what I said is I wanted to change Balrog. So let's go to Balrog's code. That's this tab here. At the most basic file, we'll just quickly open up MoveGen. This is the code which actually just creates all the moves that are possible on the board. So it uses bitboards and all sorts of things. Now, I actually originally started by taking out en passant moves at this level, and then that gave a lot of errors, because actually when you're playing a game versus a game, this engine would have said, oh, your en passant move's illegal, I'm giving up, right? So you can't actually make it effectively. By not generating the move, you're effectively making an illegal move. So you can't use MoveGen for that. And if you look at it, MoveGen actually is called by move pick. You can see movepick.cpp. Now this actually implements another part of the the searching mechanism, and what they've done is shown that when you're doing your alpha beta search in chess moves, if you use the stronger moves first in the list, like you've got a list of legal moves, but then if you're then able to somehow pick the moves which tend to be stronger, which Stockfish kind of works out by the fact that move in similar positions, e4 is always strong, so we'll put e4 first. If you do that, it actually makes the pruning of the weaker moves much faster, because when they come along, strong moves already be considered the weaker move, it gets pruned off very quickly, right? So move picker actually seems to be the one which gives the moves, the legal moves, orders them so that the stronger moves are returned first. So we've actually got to go one more further back to search.cpp, which is where we're going to make our change. It's looping through the moves, going to pick one. So if the move is en passant move, I'm never going to pick it, right? So I will never pick it as my move, and therefore the other computer may be considering it, and you play more weakly. So let's just I'll write that, and I'll quit, and make -j build arch architecture equals native. It's probably only recompiling search.cpp. So what I will do now is we'll go to QGIS. So we now have the Balrog, can't do en passant, versus Gandalf, who can, and we're going to really push it. We might make the time control a little bit better, right? And then we will also make it a few more rounds, get a better result, and we'll let it run. Okay, so it's concurrency is 10, start up 10 games. When one game finishes, the next game will start, all that sort of stuff. So obviously, I'm going to stop the video here, and I will come back when this process is complete. Okay, welcome back. So it has finished, and you can see that of the 50 games we've played, that Gandalf won 2 games and Black won none. So it's not a big difference. It's like ELO difference of 14 according to that. Okay, I wasn't very happy with that. So after the recording, I went back and did a bit more testing. I played another 50 games, Gandalf versus the Balrog, and the same thing, Gandalf was winning 2 extra games. So what I then realized is I'd forgotten another section of the code where I needed to put the same 2 lines of, if the move is an en passant move, ignore it, right? So that version I had was more like Bilbo standing on the bridge than Gandalf. And when I made that change, you can see the impact it's had on it now, that now it's sort of en passant in all cases. And you can see the result with 20 wins to the machine, which could do en passant out of 50 games. So, and then the ELO difference is 147. Now I quickly look at one of those games. I mean, here's an example. I mean, the screen's a bit, bring it down, a bit small. So in this position, Balrog was white and thought it would play g4 check, and basically winning from the fact that black can play en passant. So that's a sort of situation which it's obviously very dependent on the game. Is there a en passant possible, and does that en passant have a big impact? And obviously the statistics of those two situations lead to the outcome. 150 ELO difference seems a bit more reasonable, but it still means that Stockfish, novel Stockfish like that, is still a very powerful engine. And so I think that's sort of all I wanted to talk about today. So that gives you a brief overview of QChess. and how to poke around with Stockfish in particular, and maybe come up with your own versions of some of these chess engines, or develop your own and test it against Stockfish. QJet Chess, and particularly the command line version of it is what you could be using. Okay, thank you very much for watching.